Yes, good evening.
Yeah. I've got the board fixed.
Yes, 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 I see backside your whiteboard.
Okay.
Yes. So first of all, basics, introduce yourself.
Okay. Good evening, sir. My name is Siddharth-CHEM, and I have done my schooling from St. Anselm Senior Secondary School, Bhilwara, and then I went for my graduation to the Central University of Rajasthan. Then in 2017, I qualified the IIT-JAM exam, and after that, I went for my post-graduation to Indian Institute of Science, Bangalore.
Yeah.
And after the completion of my post-graduation, I have qualified CSI and NET and in recent times.
Yes, good. Yes, today mock topic is reaction mechanism.
Yes, sir.
Yes. And explain on whiteboard.
Okay, sir.
Yes, let me start.
Sir, it's visible.
Yes, yes, visible. Yes, clear, visible. Yes.
So, sir, when we talk about reaction mechanism, the first thing comes in our mind, what is the use of reaction mechanism or why we need to study the reaction mechanism?
Yes.
So, the principle which is underlying a reaction can be explained with the help of reaction mechanism. For example, if we want to find out what is the product form, that we can easily determine. But how that product is forming, that for that understanding, we need to study the reaction mechanism so that we can understand how that product is how a reactant is getting converted into the product. For example, in organic chemistry, if we see any reaction like Rx is getting converted if OH minus is given here and it is getting converted into ROH. So we know that okay, alkyl halide is converting into alcohol, but how this is happening or what is the mechanism behind this, that we need to study. So for that we need the reaction mechanism. So in organic chemistry we are having four type of reaction mechanisms basically. So the four types are, first one is substitution reactions. Second one is addition reactions. Third one is elimination reactions. And fourth one are rearrangement reactions. So the substitution reactions are further classified into three categories, which are SN1, which is nucleophilic substitution of first order, SN2, which is nucleophilic substitution of second order, and SNI, which is nucleophilic substitution intramolecular. Then the addition reactions are of two types: nucleophilic addition reactions and electrophilic addition reactions. And the elimination reactions are also of three types. One is even elimination, which is elimination reaction of first order. Second one is E2 elimination, elimination reaction of second order. And even CB, elimination reaction by conjugate base mechanism. And the rearrangement reactions are of different types, and there are many types of different rearrangement reactions. So they are not classified as such. So we will start with the nuclear substitution reaction. So in substitution reactions, we are having nucleophilic substitution reaction first. So in nucleophilic substitution reactions, we are having first SN1 reaction. So in SN1 reaction, the basic principle which is underlying that a molecule Rx, where X is a leaving group, this one is a leaving group, in presence of a protonated solvent, gets converted to R plus, because this X minus leaves as HX. and there is a formation of carbocation. Now a nucleophile comes and attacks on this carbocation because carbocations are unstable and they can easily accept electron. So this nucleophile comes and attacks on that and makes the formation of R nucleophile bond. So why this is SN1 reaction or first order reaction? So for that means we can say that when this formation of carbocation is happening, so it is the slowest process in this step and it is the rate determining step. So this formation of carbocation depends only on the presence of this Rx or the alkyl halide or any means organic moiety with the living group. So the reaction having a rate which is proportional to the rate is directly proportional to the concentration of the Rx. That's why this reaction is called as nucleophilic substitution reaction of first order. Now there are some other important factors about this reaction. So first important factor that we know is that it's a first order reaction. Second important factor is that it involves the formation of the carbocation. So based on the formation of carbocation, we can determine the rate of reactions. Like if we are having a molecule, for example CH3X, then it will form the carbocation CH3 positive. And if we are having a molecule like CH3CH2X, it will form the carbocation CH3CH2 positive. So if we compare both the molecules, then we will see that the first carbocation is comparatively less stable as compared to the second carbocation, because in the second carbocation we are having three hyperconjugated structures or the positive charge is stabilized by the hyperconjugation. So we can say that the second reaction will progress much faster than the first reaction. So based on this, we get a order of reactants which show the SN1 mechanism. So SN1 reaction rate order. So it's like methyl is the least reactive, then we have primary halide, then we have secondary halide, then we have tertiary halide, then we have allylic halide, and the most reactive are benzylic halide. So benzylic halides are stabilized by the resonance, so they are the most reactive and they give the SN1 reactions very easily. So now let's move to the SN2 reaction. So SN2 reaction is biomolecular or second order nucleophilic substitution reaction. So why it is called as SN2? So for that, now in case of SN2, there is one substrate Rx, let's assume, and the nucleophile. So in this SN2 reaction, there is no formation of intermediate. It's a complete one-step reaction. So in this case, there is a formation of the transition state in which the nucleophile attacks on the R moiety and it attacks on the back side of the Rx bond. So this is the transition state that forms, and finally this gets converted into the nucleophilic R. Now the main feature that why it is biomolecular reaction, because here if we see that the formation of the product is not independent of the concentration of the nucleophile, because the nucleophile and Rx both are taking part in the reaction. So we can say that the rate is directly proportional to the concentration of Rx and the concentration of the nucleophile. That's why it's called as a second order nucleophilic substitution reaction. Now, what are the important features of this? So, first important feature of this is that there is a formation of the transition state. So, if we compare the reactivity of the different substrates in the reaction, then we will see that if a molecule is there, like CH3X is there, and if we try to do SN2 reaction on this molecule, then it will form transition state this transition state. And if we try to form C2H5 and nucleophile attacks on this, then it will lead to the formation of transition state, which is now. If we compare both the transition states, then we will see that the first transition state is relatively more stable because here there are no bulky substituents attached to the carbon on which the nucleophile is attacking, while the second transition state is comparatively less stable. So we can say that the formation of this transition state will be more faster as compared to the formation of the second transition state. So the reactivity of the CH3X for the SN2 reaction will be much faster than the reactivity of C2H5X. And based on this, we find the reaction order for the SN2 reaction as that methyl substrate is more reactive than primary halide, which is more reactive than secondary halide, and which is more reactive than the tertiary halide. And one important feature of the SN2 reaction is that there is always an inversion of the configuration in case of the nucleophilic substitution, because the nucleophile that is incoming on the Rx, it's always from the back side of this Rx bond. So when the product will be formed, the nucleophile will attack from back side and it will form bond in the other configuration of the R. So if R is a chiral center, then we will observe that the product that is formed is the inverse configuration as it was there in the Rx. So now let's move to the addition reactions. So in case of addition reaction, we find two types of addition reaction. One is nucleophilic substitution, nucleophilic addition reaction, and other one is electrophilic addition reaction. So nucleophilic addition reactions, as name suggests, is the addition of the nucleophile first, then the addition of electrophile occurs. So for the nucleophilic addition reaction, we need a center where the positive charge or the partial positive charge is there, so that the nucleophile can first attack and add to that substrate. So the best substrates for the nucleophilic substitution reaction are the carbonyl compounds, because in carbonyl compounds we have del positive and del negative. So if a carbon compound like carbonyl or R C triple bond N, because here also the positive charge is there on the carbon and negative charge. So if a carbon is attached to any heteroatom, then we can say that it will possibly go the nucleophilic substitution, nucleophilic addition reaction. So the main features of the nucleophilic addition reaction are in case of addition of like LiAlH4, it goes to the formation of. So if we study the mechanism of this reaction, we find that first the electrons on this attack on the lithium ion and leads to the formation of. Now is negatively charged, gives its hydrogen, and the electron shift here. So this is the formation of the product, and when we hydrolyze this, we get the desired product. So this is an example of nucleophilic substitution reaction, because here the H minus is acting as a nucleophile and is adding to the carbonyl carbon. So the main feature of this nucleophilic substitution reaction is that we need a substrate which is having a polarity in the bond. First thing. Second thing, for a nucleophilic substitution reaction, the rate or the concentration of the nucleophile and the reactant. Both are important. So we need to focus on the concentrations of both the reactants. Now, nuclear electrophilic addition reaction. So in the electrophilic addition reaction, as the name suggests, the electrophile first adds to the reactant molecule. So for the electrophile to add to the reactant molecule, we need the reactant molecule to be an electron-rich species. So as we can see, in case of C double bond C or alkenes, if we add any electrophile, then this double bond which is having more number of, which is having a electron density, can attack on the electrophile and lead to the formation of the carbocation. And after the formation of the carbocation, the nucleophile can attack on this and it can lead to the formation of product. Now, in case of the electrophilic addition reaction, we see that there is a formation of the carbocation. So this formation of the carbocation is most important step in this reaction, and it is also the rate determining step also, because for the formation of the carbocation, the more stable the carbocation will be, the reaction will progress more faster. As we can see, if we substitute the alkene and add the H plus ion on this, so the formation of this product is much faster in comparison if we take normal ethene and add H plus ion, then the formation. Because here the carbocation that is formed is a 3-degree carbocation as compared to the primary carbocation. So 3-degree carbocation is more stable. So the reaction in this case will progress much faster. Also, in case of the electrophilic addition reaction, the formation of carbocation determines the regioselectivity of the products also. For example, if we see, if we say that this molecule is reacting with the electrophile, okay, in presence of H plus. So there are two possibilities. There can be formation of carbocation here also and here also. Since we know that the more stable carbocation will be formed because it's the rate determining step, and the more stable carbocation will always be there. So the addition of H plus will take place on this carbon, and we will observe a formation of the tertiary carbon. So the formation of the carbocation determines the regioselectivity, that the nucleophile which is incoming will always attack on this carbon only, not on this carbon. So this product will be the major product in case of the reaction. Now let's move to the elimination reaction. So in case of elimination reaction, we are having 3 types of elimination reactions. First is E1, second one is E2 reaction, and third one is E1-CD reaction. So E1, as from the name suggests, E1 is the first order elimination reactions. So in the first order elimination reactions, we find that if a leaving group is there, the leaving group is there, then the base or the protonated solvent you can use. So in case of the protonated solvent, X minus donate its electron pair, it will take also, and there will be a formation of the carbocation. So in the even elimination reaction, the formation of this carbocation is a rate determining step because it's the slowest step, and based on this we can say that the even rate is directly proportional to the concentration of the reactant. It does not depend on the presence of the other substrate, which is a acid or the base. And now in case of E2 elimination, you can see that as the name of E2 elimination suggests, that it's a bimolecular or second order elimination reaction. So here we have the substrate like CC. With a given group H. So the reaction will progress in one step only, and it will depend on the concentration of the reactant also, and also on the concentration of the base. Now, the mechanism of the reaction is as such, like OH minus or base, you can see base will attack on this hydrogen. This hydrogen will leave, and this leaving group will leave from it. And in the single step, there is a formation of the transition state. This is the transition state that has formed, and in the single step only, it will lead to the product. Now, why this rate means this reaction is bimolecular or second order? That's because the rate of this reaction depends on the substrate also and the OH minus also, because both concentrations are affecting the reaction. So we can say that it's a second order. And the most important point of the E2 elimination is that there needs to be anti-periplanar geometry between this hydrogen and the leaving group, because this reaction is happening in a single step. So for the transition state to form, there needs to be anti-periplanar geometry. And why this anti-periplanar geometry is important? So you can see that
Yes.
there is there are orbitals. From this, the hydrogen is attached. From this, the leaving group is attached. So when the base will attack on this hydrogen, so this orbital needs to be vacant so that these two electrons which are bonded with the carbon can be transferred to the orbital of to the antibonding orbital of this leaving group sigma of the sigma star of this C leaving group orbital. So when the two electrons will transfer, this bond will get broken and there will be a formation of the bond like this. So for this we need the anti-periplanar geometry in the E2 elimination. Now the third one elimination reaction is even CB, which is the elimination reaction by conjugate base mechanism. Now in this reaction mechanism, we need a special type of substrate because this And reaction proceeds by the formation of the carbon ion. And like if we are having a electron withdrawing group instead of carbon here, and a hydrogen and a leaving group is so if we use a base in this case, so this base will attack on this hydrogen and lead to the formation of the carbon ion. Now, for the formation of the carbon, we need an electron withdrawing group so that the carbon is stable by this electron withdrawing group. And the formation of the carbon is only possible because of the stabilizing effect that is produced by the electron withdrawing group. So, after the formation of the carbon, this on this carbon, and it will lead to the formation of this. Now, in this reaction, the formation of the carbon is the rate determining step because it's the slowest step, and the stability of the carbon here determines how fast the rate will progress or how slow the reaction will progress. Now, the last reaction mechanism that we are having is the rearrangement reaction. Now, in case of rearrangement reactions, we are having the same substrate. In rearrangement, we say that the substrate and the products are almost similar, but they are differing in the structure. Like you say, if we talk about Wagner-Mervin rearrangement, it is a rearrangement which proceeds with formation of carbonate. Now, the rearrangement that will occur will be as such: if we are having a substrate like this, and if we protonate this substrate in presence of acid, then this X minus will attack on this and it will lead to the point. The formation of 2-degree carbocation. But see, in this case, we can see that there is a possibility of formation of 3-degree carbocation. So the 2-degree carbocation can easily rearrange by 1,2 hydride shift, and it can lead to the formation of 3-degree carbocation. Now this 3-degree carbocation can easily lose the H plus ion and lead to the formation of the. So the rearrangement that is occurring here by the 1,2 hydride shift, that's why these are called as rearrangement reaction. And there are different type of rearrangement reaction, like Beckmann rearrangement. We can say pinapole rearrangement is there. Curtius rearrangement, especially in case of the intermediates, there are many type of rearrangements that occur. So from this we can predict the mechanism of the rearrangement.
Yes, good. Yes, complete.
Yes, sir, complete.
Next point is, what is the difference between elimination and substitution?
Sir, elimination reactions proceed by the removal of the groups. Like in case of elimination reaction, if we are having
Yes.
like R, R prime, R double prime, R. If a 3-degree substrate is there, in case of elimination reaction, the product form will be having unsaturation, and the two H and X groups will leave from here. But if we do substitution reaction on this, then it will lead to the formation of a 3-degree substrate only, but with a different group in presence instead of the leaving group. Here, the leaving group will not leave from the reactant molecule. This is the basic difference between elimination and the.
Yes, yes. What is the difference between Hofmann rule and SubodhCheM?
The Hofmann rule predicts the stability of alkene. Both the rules predict the stability of alkene, but the different conditions. Like in case of the SubodhCheM, it says that the more stable the alkene will form if there are no presence of free radicals. So, okay, let's take yes. So in case of SubodhCheM product, there will be the most stable alkene form, which is the more substituted alkene. But if this goes under Hofmann elimination, then it will form the least stable alkene or the alkene with less number of hydrogen atoms, like this.
Yes. Next point is, what is the difference between E2 and SN2?
Okay, A2 elimination and SN2 elimination both are bimolecular reaction, but as the nucleophilic substitutions are different from eliminations, like in E2 there will be a formation of alkene, but in SN2 reaction, again we will get the substrate, saturated substrate only, but with a different nucleophile. And also in case of E2, like we have anti-periplanar geometry is a must, but in SN2 reaction we got an inversion product. So the reactions are happening from the backside attacks only in both cases, but the products that we are obtaining are totally different in both the reactions.
Yes, good. Now, what is the difference SN2 and SNI?
Okay. So, in SN2 reaction, when we have SN2 reaction, like, and if we have in chiral center, X, Y, Z are the group, and Z is the leaving group, in the R configuration, then in the product, the nucleophile will attack, we will get a substrate with S, and there will be 100% inversion. But in case of SNI reaction, if we have the same substrate and the nucleophile attacks, because it attacks from the intermolecular part in intermolecular phase, so we can say that there will be 100% retention of the configuration, and we will get the R configuration only if the priority orders remain same. So this is the main difference between SNI and SN2H.
Yes, good. And next, what is the difference between addition free radical and substitution free radical? What is the difference?
So in case of free radical addition reactions, like if any unsaturated substrate is there and are not radical adds, so there will be a formation of a radical in this case, but the final product will be a saturated product with the addition of the. So here the unsaturated product is getting converted into a saturated product. But in case of substitution reaction with free radical, there will be a formation of the free radical at first instant as in case of the addition reaction. But here the substrate which we are taking is a saturated substrate, and the formation of the final substrate will also be a saturated substrate. So this is the basic difference between the nucleophilic substitution by free radical and addition by free. We will finally the substrate we will get will be saturated in both the cases, but here the reactants are totally different in both the cases.
Yes, good. What is the effect of temperature on elimination and substitution reactions?
The effect of temperature.
Yes, effect of temperature on elimination and substitution reactions.
Sir, in case of the elimination reactions, since we need the bond energy to form, since the bond needs to be formed between the substrate and the reagent, so we need the energy. Sorry, there will be a release of energy in the formation of the bond. So if we increase the temperature, the rate of the elimination reaction will decrease. But in case of the substitution reaction, there is a first blow. Means we need to break a bond in case of the substitution reaction. Like in case of Rx, we need to break this Rx bond first. So we need energy for that. So if we increase the temperature, the rate of the reaction will definitely increase in this case.
Yes, good. Yes, good. आपने बहुत अच्छा explain किया. You have well explained on whiteboard. Yes. आपको आप बैठ जाइए. Sit down. Yes. Yes. एक फर्स्ट पॉइंट हमें ये मेंशन करना है. आपने जो एक्सप्लेन किया था, आपको एक तो लेफ्ट साइड आपको एक डेट मेंशन करनी है. जैसे आप जाते हो, आई एम गोइंग टू स्टार्ट इन टॉपिक ऑफ रिएक्शन मैकेनिज्म. यस, तो फर्स्ट बेसिक्स टॉपिक रिएक्शन मैकेनिज्म एंड लेफ्ट साइड डेट. यस, तो बेसिक्स रिएक्शन मैकेनिज्म है, उसके बारे में एक्सप्लेन कीजिए थोड़ा. और ऐसा कोशिश कीजिए रिएक्शन मैकेनिज्म जो आप बोल रहे हैं वो ठीक है, उस पर लिख दीजिए व्हाट इज रिएक्शन मैकेनिज्म. यस, एंड हाउ मेनी टाइप्स ऑफ रिएक्शन मैकेनिज्म. यस, बाकी आपने बहुत अच्छा एक्सप्लेन किया. गुड एक्सप्लेन, गुड, वेल एक्सप्लेन ऑन बोर्ड, व्हाइट बोर्ड. अच्छा, डे बाई डे इम्प्रूव योर mock and your explanation. यस, नेक्स्ट डे हम डिस्कस करेंगे कंबाइंड. यस, coordination, random. Yes, coordination, chemical kinetics and reaction.
Okay, sir.
Yes.
Okay.
Any your